let's start now. Okay, so yes, yes, please. Now we are going to start chapter number 3, which is yes. Now, as I told you, I have the YouTube channel, so you can subscribe it, like it if you like it, and if you don't like, you can dislike it. La mushkila. And you can press the bell button so that you can be notified whenever I upload new. You can have it. So Blackboard, this is the Blackboard technology. So the chapter is vectors and two-dimensional motions. Vectors and two-dimensional motions. So vectors we'll discuss in detail. We already discussed vectors, displacement, velocity, acceleration, they were vector, and the distance and height, they were scalars. So, and the two-dimensional motions. So first you see, you have seen in chapter number 2 that we discussed motion along a single line. We call it one-dimensional motion, whether you are moving along x-axis or some object is going up or coming down. That was one-dimensional motion along a single line. The line may be straight, it may be a curved. Right. Now, whenever you kick a football in the football ground, football travels horizontal displacement x and also goes vertical height y, and it comes down slowly. Height is decreasing and it goes to the ground again. So x-axis and y-axis motion at the same time. So we call it two-dimensional motion. So we will discuss in detail. As you see this animation, this is event on the border between states and Mexico, and there is one launcher. A person is launched and he goes to the other side of the border. Can you hear me? Okay, good. Right. Okay. So what we will be discussing in this chapter, it's 100%. Right. What are the learning objectives? What we will be discussing in this chapter? So we'll identify the difference between the scalars and vectors. We already discussed in chapter number 2 that if you have magnitude, like I say, okay, 2 meters per second, and in the direction of x-axis positive, or making some angle 35 degree with x-axis, so that is vector. You need magnitude, for example 2 meters per second, and direction. We call them vectors. And if you don't need direction, only magnitude or the value, we call them scalar. Okay, like distance. So what is a unit vector? We'll be discussing how we add the vectors and how we subtract them. What are the components of a vector, x and y component? Calculate and examine the resultant vector. What is the resultant vector? Some groups may have done experiment yesterday and today in the lab 606 and 607 perhaps. That is the object in equilibrium. So we use this method, components of a vector and how you add two vectors. You have done it already. Some groups will be doing next week. Examine and calculate the resultant vector. Okay. Describe and explain projectile motion. This is what I showed you the animation in the beginning of the chapter, when a launcher launches a person from one side of the border between America and Mexico, and he falls on the other side of the border. So that's the projectile motion at a time two-dimensional motion, x-axis and y-axis, both simultaneously at the same time. Describe forces acting on the projectile. What forces are acting on the projectile? Projectile meaning whenever you throw an object in two dimensions, we call it a projectile. We will discuss in detail, don't worry. And calculate the time and maximum height and all these things. Scalar, as I told you, scalar quantity, they can be completely explained, specified only by the magnitude, no direction. For example, I say 20-degree temperature, 90 meter per second speed, distance of 2 meter are all scalars. Vector, magnitude and direction both. Examples of vectors include velocity. For example, I say 90 meter per second east. Okay, directions can be shown like east, west, north, south, are positive x-axis, negative x-axis, positive y-axis up and negative y-axis down. Or sometime we use how much angle some vector is making. For example, this is x-axis and this is a vector, how much angle it is making with the x-axis. So we use degree also, angle also to show the direction. We see positive x-axis, negative, positive y, negative y, or east, west, north, south. So we do use different methods. All right. Now, properties of a vector. You see, A vector and B vector. You see, as I told you, we show the direction. And for example, if you have any vector, I say, okay, A vector, we show it any alphabet like A and arrowhead on its head. So this is vector. But if I write simply this, it means only magnitude. It's not vector. This is vector. This is scalar, not vector. Because here I have arrowhead. This shows this is vector. And we show the vectors with a line. Length of the line shows the magnitude. For example, I say, okay, 2 meter per second. And this arrowhead shows the direction. Now, if you have two vectors, right, any two vectors, A and B, they are called equal. When? If they have the same magnitude and same direction. For example, I say, okay, this is, y-axis, this is x-axis. Okay. Now, if I have, for example, 1, 2, 3, 4, 5. If I have this vector A and this vector B, are they equal or not? Yes? They are equal. Why? Because they are in the same direction towards positive x-axis. And also, if you look at the magnitude, this is 0 from here up to here, A vector. How much? 2 magnitudes, huh? And from here it has the same 2 magnitude. This, its magnitude is 2, its magnitude is 2, huh? Both are equal. Same magnitude, same direction. So they are equal vectors. Clear? Good. Now, how we add the vectors, addition of two vectors? There is a rule. Keep in mind that adding two vectors is not equal to adding two simple numbers. For example, if I add 3 and 4 equal. If I add two numbers 3 and 4 equal what? 3 plus 4? 3 plus 4? 3 plus 4? 7. 3 plus 4 equals 7. When I add simple numbers, first I'm asking about simple numbers, right? And you are right, yes, that when you add two vectors, one having magnitude 3 for example, and the second one having 4, the resultant vector is not having 7. So this will be 5. How we use Pythagoras theorem. 3 square plus 4 square under the root equal this, which will be 5 when we add two vectors. So keep in mind that adding two simple numbers and adding two vectors, both are entirely different things. What is the rule of adding two vectors? The rule is that if you are given two vectors, okay, I say you have you have these two vectors. This is vector A and this is vector B. This is the beginning of the vector, this is end. This is beginning, this is end, or we say tail and head. The rule of adding two vectors, we write like this one. That's A vector plus B vector is equal to the result of that addition. We call it the resultant vector. Okay, so this R is the resultant vector. Now we write like this one, and keep in mind, if you have 3 and 4 like this one, we don't write 3 plus 2 because that's the magnitude. So magnitude we find with Pythagoras theorem, or we measure with the ruler. For example, the rule is, try to understand the rule first of all. What we do, take the first vector which is in the addition, which is A here, as it is, like this one. I put it here A. Bring the beginning of the second vector B at the end of the first here, and with the same direction and the same length, and finally join this beginning of the first to the end of the second vector. So this is your resultant. And as I told you, we are talking about vectors, so the resultant vector must be having a direction and magnitude. Okay, this is a way of writing. It does not mean that you have A simply plus B magnitude is equal to resultant magnitude. No, this is a way, a method of writing that A vector plus B vector is equal to R vector resultant. So you can measure the length and that will be the resultant. Okay, now negative of a vector. You see, if you have any vector, for example, I say you have any vector A in this direction having magnitude, I say okay 1 2. Okay, if I have another vector having the same magnitude 1 and 2 but in opposite direction, this is called minus A vector, negative of a vector. Okay, simply that. Right, so negative vector is a vector which is having the same magnitude but in the opposite direction, 180 degree different. Now if you add a vector, any vector with negative of that vector, you will be getting 0 answer. Okay, now how we subtract the vector negative, I mean A vector. Before we did A vector plus B vector. Now we are going to have A vector minus B vector. I will be using the same method of adding two vectors, which is A vector plus another vector. We add them. What we do, this minus I write plus and in bracket minus. What does it mean? that okay, this is a minus b, you have to find out, but I take it positive here so that I need two vectors. One vector is a, for example, you are given this vector a and you are given this vector b, but you need to add two vectors. One vector is a, this vector, okay. The other vector you need minus b. So b is this one and minus b will be like this, okay. So you have to add these two vectors now, okay. We don't need b vector, we need minus b and a. Here a vector addition with minus b. Now here what we do, we bring the first vector a as it is. This is the a vector, I bring it here, you see here, and bring the beginning of the second vector which is minus b now at the end of the first. This is minus b here. So join the beginning of the first to the end of the second. This will be your resultant vector now, which is a vector minus b vector, which is in fact a vector plus minus b vectors. So only you use this concept idea of negative vector. Any vector b is given to you, you see here, you take the same magnitude but in the opposite direction and you add it with the first vector. That's it. Clear? Yeah. Yeah, when you have minus like this one. So we replace minus by plus but taking the vector negative, so minus b for example. Yes please. Yes, this is from book. Right. Next topic is components of a vector. Components of a vector mean parts. Okay. So we are going to find the parts of a vector. One is along x-axis, just x, and the second one y. All right. Now, for example, you have any vector a. This is x-axis, y-axis. This is the origin 0, 0. Any vector a making some angle theta with the x-axis. If I draw a perpendicular from this point on the x-axis, okay. Now this is along the x-axis, okay. This is the y-axis, this one, and also this is the same. This is x-axis and this is y-axis. So what does it mean? It means this is vector a, original vector, sa red color, and this is along x-axis. This is I call it x component of vector, and this is y component of vector. Okay, this is original vector. So we have two parts of this vector a, one along x-axis, one along y-axis. You see, you have done in the trigonometry course that trigonometric identities, that if you have, for example, sine theta, if you have this triangle, sine theta will be equal to ay divided by hypotenuse a. This will give you ay is equal to what? Yes? A sine theta. Similarly, if you have another trigonometric identity, cosine of theta is equal to base ax over hypotenuse. So you get x component of vector a cosine theta. Clear? Good. You see, now we call it x component and this is the y component. Now if you are given theta and vector A magnitude, so you can easily find out x and y components, right? And this is, if you are given A and theta, you can find out ax and ay. But if you are given ax and ay, you can find out the magnitude of resultant vector A by Pythagoras theorem. This is the triangle, right angle triangle. This is ax, this is ay, this is again ay. So this is also ay. This is theta. In front of theta, you have perpendicular, Umud, right? This is hypotenuse. Okay, this is base. Now, you know that Pythagoras theorem, we write it like this one: a square is equal to ax square plus a y square. So taking the square root, you get this rule. So magnitude like this one. If you have ax, you have ay, you can easily find out the magnitude. Clear? Okay. Great. Now, as we are discussing that we are dealing with the vectors, so magnitude and direction both they have. So this is the magnitude, as I told you. This A is the magnitude of vector A. Now for direction, we are using the same triangle. Tangent of theta, ay over ax. I take this tangent to the other side, it will become tan inverse ay over ax. So this is the way you will be finding out, you know, the direction for that. Okay, so now to find out the direction, we use the tangent. Okay. Right. Now you see, it depends now. For example, sometimes keep in mind that when we are dealing with the direction of the vectors, if in this case you see this is the first quadrant, right? This is the first quadrant, this is second, sir. Okay, that's right. And this is the third quadrant. Okay, and this is the fourth quadrant. Am I right? Right. If you are in the first quadrant like this one, this vector is making angle theta from the positive x-axis, sir. Okay. Keep in mind that in general, mostly we are interested for any vector direction theta from the positive x-axis, like this one going anti-clockwise. Anti-clockwise direction, we take positive from positive x-axis. Clear? Okay. Don't forget this. Now, if you are in the second quadrant here, for example, this is theta, for example, this is your ax, for example, and this is your ay, for example, and this is a. You see, now this is x-axis, this is along negative x-axis, huh? Okay. Right. Now this angle will be negative. Why? Because it is not from positive x-axis this direction, it is from negative x-axis opposite direction. You get the point? This will be negative angle. Now whenever you are solving the questions, you are being asked to find the direction theta from positive x-axis, right? If I take this is positive, can you see from here up to here this angle if you need? So what we do, from here up to here, how much total angle? Again, from here up to here, how much angle? 180. Great. Now 180 minus this one, I'll be getting this angle, right? Okay, again this is 180 degree. 180 degree minus this theta, I'll be getting this angle from positive x-axis this side. Okay, as a rule we take this angle positive from positive x-axis to anti-clockwise, opposite to the clock. Okay, right? بالعكس أقارب ساعة. Okay, so we take positive. Now even if you have, for example, third quadrant, here any vector A, this is ax, this is theta, and this is y, ay. You see, as I told you in the second quadrant, so this is total 180 minus theta. For example, if this theta is 30 degrees, so 180 minus 30, you will be having 150 degree. So the angle from the positive x-axis will be 150. Similarly, if you are here, now the angle from positive x-axis is this, which is 180 plus theta. So from here up to here 180, sir. And this is theta, so I have to come up to here. So 180 plus theta in this case. 180 plus theta. And here we did 180 minus theta. Right? The angle from the positive x-axis when you are asked in the question. Normally you have to do that. Now, if you have, for example, one minute. Okay, now if you have, for example, a third quadrant like this one, we'll discuss later on, don't worry, inshallah. Now let's go to the next question now. Please take 2 minutes to read this question, then I will solve it. Please try to understand what is inside the question. Yes, please. Should I solve it now? Hello? Good. Okay. Now, you see, find the horizontal and vertical component. You have to find out, sorry. X component and Y component. So X and Y components of this displacement vector, you have to do it.
So teacher, we have the D and the theta, right?
Yeah.
We don't have the X or the Y.
Yes, you have to find out. So we will be using our knowledge of what we just finished.
It's sine theta, right?
Yes, please. This is page number 60. Maybe some books they have different. Right, let's do it now. So let's do it now. X-axis and Y-axis component of this. So you have right. So you have first of all decide. You see, first of all you have to decide. First of all, D is given to you, or I call it, for example, A vector or D vector, the same meaning, by the way. Right? We have A vector 1 multiplied by 2, which is 100 meter, right? And theta is equal to how much theta? Yes? No. Minus 30. Ask why. Ask why. Yes, because you see, I told you when the angle is from the positive x-axis this direction, anti-clockwise, as a rule, we set the rule that when you take the angle from positive x-axis to anti-clockwise direction, we take angle positive, and this angle is from positive downward, opposite direction. You get the point? So we take minus 30 degree. Clear? Again.
Can I say 350?
Yes, you can say. You can say, because 360 minus that, what is the same thing? If you use the calculator, you will be having the same value. Minus 30 degree or 330 will give you the same value for sine or cosine. That's right. Now, so what we do, we take this negative, and now we are going to use the x and y component. So first of all, x component is equal to a cosine theta, right? And then let me complete this one. A cosine of minus 30 is equal to,
Why minus theta?
I told you, gentlemen, that from positive x-axis, when you go to the anti-clockwise direction, as a rule we take positive angle. This angle is not that. This angle is from positive clockwise. So clockwise we take negative angle. That's the reason. Clear? Right. Now you have another identity that cosine of minus angle is simply equal to cosine of angle, and sine of minus angle is equal to minus outside sine of angle, sine of theta. These are the two identities we frequently use in trigonometry as a rule. You might have done it maybe in your trigonometry course. Right. Now, yes please. A is displacement, in fact. This is A or D, the same meaning. Displacement or A vector is the same. Okay?
Excuse me, teacher.
Yeah.
Can I take the sine, not cosine?
This is cosine. AX is equal to A cosine theta. We just finished. Okay?
But I can take a sine, right?
No, gentlemen. You see, x component AX is equal to A cosine theta. Okay? This is what I'm doing, A cosine theta. Now, you will get the answer if you use the calculator, 86.6 meter. This is the x component which you are about to find out. Now, we are going to do now y component. We have this rule, A, we did it already, sine theta, A 100, sine minus 30 is equal to minus this rule, sine of minus 30 is equal to minus sine theta. Okay, so we are doing like this one. So this is equal to minus 50 meter. You see, if you keep in mind the vector addition rule, right? So what is that rule? That this is your x component, which is going in the positive x direction, you see, and y component is going down, which is along the negative y axis, should be negative. That's the reason you have y component here minus. So this is automatically checked, you see, because you have two vectors here. One vector this direction, this is beginning of the vector, and this is the end of the vector here, and we bring the second vector, which is y component, beginning here and end here. Okay, so this is your resultant vector A. This is how we recheck our answer. So this is part A of the question. Any problem, please?
Teacher,
Yeah.
can you repeat minus 30.
Okay. You see, first of all, keep in mind that we have set the rule that if you have any vector, for example, here, making angle theta, we take this positive because this is already in the first quadrant here. This is plus x, so from positive x-axis you are going in the anti-clockwise direction, so angle is positive. Khalas. Now if it is here, you see, it is not like clockwise, anti-clockwise, it is clockwise, so it is negative, right? Theta is minus 30. Clear? Now we have these two rules. Cosine of minus theta is equal to cosine theta, minus finish. But if you have sine of minus theta, minus becomes outside, so minus sine of 30. This is what we are doing here. Sine of minus 30, minus becomes outside, so I'm writing here outside. Clear?
Okay, teacher. The calculator minus 100 sine 30 equal not equal minus 50. Calculate.
What is your answer?
What?
What is your answer?
98.
No, you check the mode of the calculator. The mode should be at degree. If you press shift and mode, MODE mode, and then you see where what it's showing. It is showing you know, radian or degree. You set at degree.
Okay, there is many numbers. 1, 2, 3, 4.
Gentlemen, it is written. What is 1?
Degree.
Degrees, huh? Yes or no?
DEG.
Ah, yes. Press this one. Press this one.
Okay.
And check it again.
Okay.
Now it will be minus 50, inshallah. I'm getting.
Yes, that's right. Sorry.
Good, good. Right. Let's go to the B part now, please. Yeah. B part. Now, suppose instead a superhero. Okay. Superhero. Help is on the way. Okay. Superhero is superhero. رجل الخارق, صح? Right. So he is going in the opposite direction now, and it's given to you that now you are given x component and y component, right? X component B. You see, x component of B is minus 25. Okay, I say okay. This is x-axis here. Bx minus directions, huh? And y component of B is plus. Up is plus, huh? Okay. This will be your, from the beginning up to the end here, this is your B. Okay, this is Bx, this is By, and this is B. Find the magnitude and direction of displacement vector. Now displacement vector is B. You have to find out. I put, sorry?
Right?
Hmm?
That time, right? Or what?
Right, for direction 10, yes. Magnitude and direction both. So magnitude by Pythagoras theorem and direction by tangent theta. Right? Let's do it. First of all, let's do the magnitude. Bx how much?
Minus 20.
You get this one. This is the magnitude. Sorry. Okay. This is the magnitude. Okay, and for direction, by over bx, tan inverse by 10 minus 25, you get angle minus 21.8 degree. You see why minus? As I told you that this is along the minus x-axis. If the angle is from the positive x-axis, should be positive. This is from the negative x-axis, opposite side, so this is negative. It is clear to you, right? Now we are interested to find the angle from positive x-axis. This angle we need. I give it a name phi, Greek letter phi. This is theta, this is phi. So theta you found out, this is theta. Okay, phi, this angle from the positive x-axis. This should be 180 minus theta. 180 minus 21.8. So you get how much? 158.2. Listen, don't write here 180 minus again. It will be plus, and you will be getting more than 180 of this line. So this is 180. You get the point? Sorry? Okay. Look. This is angle theta minus 28.2. It is clear, even before calculation you can say, teacher, angle will be minus. Why? Because this is your vector and this is angle theta. It is from negative x-axis this direction, sir. This should be negative. So when you calculate, you have the information given. It is automatically coming minus. Even if you don't draw this one, you will get minus. Okay, and as I told you, you are interested to find the angle from positive x-axis this side. Okay, this total is 180 degree minus theta. You will get the angle from the positive x-axis. I give it a different name because this is theta, this is phi. I cannot give the same name to both. So 180 minus theta. Please don't do minus plus here. You will be getting more than 200. That will be against the rule, because from here up to here 180 degree. Okay, so that's it. Yeah. What?
How you get the theta?
Tan theta. Oh, tan theta is by over bx. You have by this. How much? How much bx?
Minus 25.
This is what I am using here. You use the calculator, you'll get minus 21.8. Khalas. Why minus? Because the angle is from minus x-axis here. You need this angle, which is 180 minus this theta. So 180 minus this theta. Don't put minus plus again. That will be against the rule, because if you add 180 plus this, it will be more than 200. But all this should be 180. So this is the final angle from the positive. This angle is from the positive x-axis. Clear? From here up to here. Voilà. Yeah. From x-axis positive we take. From x-axis in the counterclockwise direction. Okay? Bil x. Okay? This side we take from the positive x-axis positive. If you have any other direction, theta will be negative.